Hi guys. So the question here says, a situation may be described by using different sets of coordinate axes having different orientations. Which of the following do not depend on the orientation of the axis? Now let's check each option one by one. Over here I've shown the two coordinate systems which are at an angle theta to each other. I've also drawn a vector A which is at an angle phi with respect to the initial coordinate system. I've marked the axis of the initial coordinate system as x and y and the axis of our final coordinate system as x dash and y dash. The unit vectors along x and y, I've written them as x cap and y cap, and the unit vectors along x dash and y dash as x dash cap and y dash cap. Now, for the first option, that is the value of a scalar, let's consider an object of mass m. Now, irrespective of which coordinate system we use to measure its mass, it will be the same. The same thing we can say for the length of a rod. It will be the same irrespective of which coordinate system I use to measure it. And so we can clearly see that the value of a scalar such as mass, length, it doesn't depend on which coordinate system we are using it to measure. Now, let's check the rest of the three options. The rest of the three options deal with vectors. So now let's analyze our vector A and see how it changes or doesn't change depending on our coordinate system. Now, I've written the components of vector A in our initial coordinate system and also in our final coordinate system. You can clearly see that the component changes. In the first case, its component along x-axis is mod A into cos phi, whereas in the final coordinate system, its component along x dash cap is mod A into cos of phi minus theta. And so option B is incorrect since it does depend on the orientation of the axis. The third option, that is a vector. Now this option is correct since we can see that vector A remains the same in magnitude and direction on changing the orientation of the axis. Now how does this happen? We can see that the component of A vector changes. Both the components, that is along x cap and y cap, change on changing the orientation of the axis, and yet the vector remains same. So this is an important point to note, that the components change in such a way such that their resultant gives back the same original vector. Now let's check the option D, that is the magnitude of a vector. Now we know that the magnitude of a vector is a scalar, and hence we can say that option D is correct since it does not depend on the orientation of the axis. So the final answer to this question is option A, C and D. Thank you for watching.